In this video, we're going to discuss Chebyshevs Theorem. Chebyshevs Theorem says that for any distribution, okay, so unlike the empirical rule, which is only for bell-shaped distributions or normal distributions, Chebyshevs Theorem is for any distribution. The proportion of values lying within k standard deviations of the mean is at least, okay, so it could be more, but at least 1 minus 1 over k squared, where k is greater than 1. All right, so let's go ahead and define k to be something, and then this theorem maybe it'll make more sense. All right, so let's say k equals 2. All right, so that means k is however many standard deviations from the mean. Okay, so so 2. This basically means 2 standard deviations from the mean, right? So, say we have some distribution, and it can look like anything. Doesn't need to be a normal distribution, but say here is the mean of this, and we've gone 2 standard deviations above and below the mean, and this is at least. Well, we need to figure out at least some percentage, right? That's what the Chebyshevs theorem is going to tell us. All right, so if k equals 2, the percentage then would be 1 minus 1 over 2 squared, right? 1 minus 1 over k squared. So that is 1 minus 1 over 4, which is 3/4, which is 0.75. Okay, so at least 75%. Right, so at least 75% of the values are within 2 standard deviations from the mean. Okay, so we've gone 2 standard deviations, k is 2, so within 2 standard deviations of the mean, at least 75% of the values are within 2 standard deviations of the mean. And it could be more, right? This could be 90% of the observations, right? But it's at very least, it's got to be at least 75% according to Chebyshevs theorem. All right. One more example, say k equals 3. All right. So 3 standard deviations from the mean right now. 3 standard deviations from the mean. All right. So again, say you have some distribution. It doesn't matter what the distribution. It doesn't need to look normal. But say this is what the distribution looks like. So the mean may be here. And so we go 3 standard deviations from the mean, 3 standard deviations above and below the mean. Okay, and what is at least what is the percentage between 3 standard deviations from the mean? Chebyshevs theorem would tell us it's 1 minus 1 over 3 squared, which is 1 minus 1 over 9, which is 8/9, which is 0.89 or 89%. Okay, so at least 89% of the data is within 3 standard deviations of the mean. And again, it could be more. It could be 90. It could be even 100% of the data is between 3 standard deviations of the mean. But Chebyshevs theorem tells us that it has got to be at least 89%. Right? So remember, the empirical rule said that this percentage within 2 standard deviations from the mean was 95%. Right? And so 95% is at least 75%, right? So the empirical rule said that within 2 standard deviations from the mean, it was 95% of the data is within 2 standard deviations of the mean. And the reason why it's able to be more specific is because they assumed the normal distribution, whereas Chebyshevs theorem is for any distribution. Okay. All right, so let's do an example. Say we have the mean price of houses in a neighborhood. It's 150,000, and standard deviation is 50,000. Okay, so find the price interval for which at least 75% of the houses will sell. Right? So find the price interval for which at least 75% of the houses will sell. Okay, so sometimes it's helpful to draw these out. You know, it doesn't matter what, we don't know what the distribution looks like, so I can draw it any way I want. But we know here in the center is 150,000. I'm trying to find the interval, which is at least 75% according to Chebyshevs theorem. All right. So let's see. Chebyshevs theorem says that, you know, it's going to, it would depend on what k is. So we know 1 minus 1 over k squared is going to be whatever this percentage is. So this will equal 0.75, at least 75%. Right? And since we just did an example and we showed that when k is 2, this equals 0.75, right? So 1 minus 1 over 2 squared is 0.75, right? We just showed that. So k then must be equal to 2. Right, so I need to go 2 standard deviations above and 2 standard deviations below in order to figure out what this interval is. Okay. All right, so 2 standard deviations above and 2 standard deviations below the mean. So let's see, the mean is 50,000. So 2 standard deviations below would be 2 minus 2 times the standard deviation, which is 50,000. Okay, so 2 times 50,000 is 100,000. So that would be 150 minus 100, just 50,000. Okay, and if I were to go up 2 standard deviations from the mean, okay, so that's in this direction, then I would do plus 2 times 50,000. So 150,000 plus 100,000 is 250,000. Okay, so at least 75% of the houses will sell for between 50,000, right? This is where this line is, 50,000 to 100 or 250,000. Okay, for 250,000. So 75% of the observations, or 75% of the houses will sell between 50,000 and 250,000 at least, right? And it could be all of the houses sell between 50,000 and 250,000, but Chebyshevs theorem says that it's at least 75% are going to sell between 50,000 and 250,000.